Yeah, hello and welcome everybody live from the SBS, the people here in the audience and also the people following us on the internet with today's topic, planning and designing modern DC grids. My name is Tobias. I'm working for Phoenix for 8 years. I'm the application expert when it comes down to DC technology and DC grids. Together with me today, we have Eike. Maybe Eike, you want to introduce yourself a little bit as well?
Thank you for having us. My name is Eike Töpfer. I'm the co-founder of Isaac Energy, and we are focusing on building a one-stop shop for energy systems, especially DC-coupled systems, and are offering like from feasibility studies up to fully built projects.
Correct. And we as Phoenix, we have a quite long history when it comes down to DC technology. So that means almost a decade we started with a research project, DC Industry 1 and DC Industry 2. And during all these investigations and the opportunity to having a new building built at our main headquarters in Blomberg, we decided to implement our own DC grid into that building in order to really have a blueprint for the industry, show the market that DC technology is ready. Because there's a lot of advantages with DC technology. When we look into the different areas like energy generation, storage, EV charging, and the production as well, by a closer look into these applications, we directly see that these already work with DC technology. They are DC powered. And then the idea of a DC grid is to really integrate everything and connect everything with a common DC bus. We can make the use of the recuperation energy. So that means in high dynamic processes, we can feedback the energy which is in these processes, like you know from the EV car, and feed it back to the system and raise energy efficiency. Stability is another big part of the advantages. DC grids are very easy to be handled. And this is due that we only have one parameter we need to take care of. It's the voltage. So based on the voltage gives us the information about the energy flow, where it needs to be transferred, how do we manage that. And nevertheless, we use less resources in terms of copper and components because we have less converter steps and we are running on a higher voltage. So far to theory, so when you think about building a DC grid, on paper it's quite easy. When you want to put that into practice, there are some challenges that come along with that. First question is, what is a DC grid? The other question is, do we have the right components? Where do we get the components? How about a grid management? As I said, building the sectors, the different areas, combining them to one holistic system is a whole different story. And there are also some technical hurdles. So we had some questions during the thinking process, and we came along these questions. We overcame these questions. One big part is that we are working in the OpenDC Alliance, which is an international organization based from Germany. 19 companies are currently in the organization, and we built a VDE specification. And within the specification, you find most of the answers you are coming along in terms of what is a DC grid, what are the typical topologies, what is the voltage levels. So looking into that is kind of cookbook, kind of recipe in terms of getting in touch with DC technology. Components, first, of course, we were asking ourselves, our colleagues at Phoenix Context, do we have components that are capable to be driven for the DC technologies in DC grids? And the answer was quite positive. A lot of components, due to the topology we based our DC grid on, are already capable on being powered via DC. Other components we developed. We have a smart breaker we developed. We have a special plug we developed. The power supply, stuff like that, we kind of had already off the shelf. In terms of grid management, we have a long history in AC grid management, and we kind of could deliver that knowledge to DC grid management based on our innovation platform PLC Next. And last but not least, you need to have the courage. You just need to do that. Just talking is not enough. You really need to find partners like Isaac that collaborate with us, that helped us, that built with us, and with a good partnership and the courage and the drive of innovation, these really innovative projects can be put into practice. So we did that at our All Electric Society factory at Blomberg, and with the knowledge and the experience we gained there, we were able to bring up a very cool industrial project, which Eike will now report and talk about. It's the first time we talk about that project in public, so you're very happy and the first one to hear about that. Eike, I think the stage is now yours.
Yeah, thank you very much. Yeah, the picture you see is from our first big DC coupled system customer. It's a public transport company, a private public transport company in Bavaria. The company is called Geldhauser. It's a very big one, and yeah, he trusted us that much to go this step and do this high innovative project, the DC coupled system, and how I would like to talk about how it started and how we came to the finished product. So it went live like a couple of weeks ago and will be finally finished in the first step the next weeks. All started with the challenge of the public transport companies to electrify. And as most of us maybe know that the grid is limited in a lot of places, and the challenge is in the public transport system, as for all companies, it has to be reliable, it has to be cost efficient, and every corner has to be challenged and used to drive down the costs and improve the reliability. So the first step was to do a feasibility study, to have to look at the complete need of the company, from the first electric bus to the 16th or 100th electric truck on this site, to build up a roadmap for the electrification and to see what are the best steps to start right, to have a very efficient and smooth roadmap to roll out the electrification. So during this feasibility studies, we found out that the grid connection was limited to 3 megawatt. That definitely is not enough to power up to 60 or 80 bus charging stations. And to have this high flexibility, there are charging stations planned or realized with 420 kilowatt peak and completely DC coupled. We need battery storage with more than 8 megawatt hours of capacity and 2 megawatt power. We need PV with more than 2 megawatt power on site and maybe even off site on a 1 kilometer away a field which will be directly DC coupled as well. So that was the solution we thought of in the feasibility study, and it was all do we go AC or DC? And because of the size and the flexibility we needed and the efficiency, where the bus companies count on 0.01 cent or something, so it's every person of a cent counts. And to fulfill another need, it was important to have an island mode. The transport system has to run even when the grid is down for a couple of hours or maybe a day. So that's another point for the DC system, so we can be in an island mode and be able to transport people minimum 1 day without a grid. And another important point is, as we have a system like that, we can offer we often say it's a little power factory on site, which can offer a lot to the grid as well. So we have the possibility to not even drive down costs on the sourcing side, but even on the earning side. So to make turnover from grid services and to have even more possibilities to make it work.
Yeah, and I think this project is a quite good example how Phoenix Contact and Isaac are working together. I think we started with the idea roughly more or less a year ago, a little bit longer, and we're in the phase that 90% of the project is done so far. In total, we are talking about 4.2 megawatt DC power. You mentioned the charging stations already, 420 kilowatt, and we are talking about 12 charging stations in total.
Maybe one thing to add, we had the time challenge, and everybody told us we need 1.5 years, and we did it in 3/4 of a year. So it was very fast and it was still successful, so against all odds.
Yeah, and the good thing was that we have the application example at Blomberg at our factory, which could we then scale up to that power size, which was demanded from the customer Geldhauser at the end. Yeah, we are very happy that we succeeded that, and your feasibility study is now giving the prognosis that the efficiency range will be up to 30% compared to a classical AC system. So it's not about that we think it's a cool idea. No, it's really a technology which is cost effective, which is flexible, and gives really stable grids all over the place.
Yeah, but we have like a very big challenge. Like DC systems are still a little too expensive and too unique, and that's why we took the challenge and want to industrialize it more, to look on the cost side, to drive down costs, to develop like special software and software strategies to make it more efficient, to make it more reliable, to make it more easy to roll out and scale it. Yeah. And that's why we always say we have to start with a feasibility study, because not in all places a DC system makes sense.
Correct.
So it's always to decide which is the best solution on site and at which time.
Yeah. And with the first project we have in the industry now, we think that will be a good enabler and a door opener for other industries to follow. Basically, when we talk about your capabilities as a company, besides the feasibility study, you're also the general contractor on site, right?
Yes, we do turnkey solutions. That was like the last step we did, because we did the feasibility studies. We have been the engineering office, and during all the steps and realizing this project, we realized that to industrialize it, we have to offer it as a turnkey, to have like all the quality steps we need while building it and servicing it in one place, and to make it possible that way. Yep.
Yeah. And as I said, this partnership developed over the time. We are looking into the future, and some very turnkey solutions we offer from Phoenix Contact into that project are, for example, our power supply system. So we do have the active in-feed converters to building up the DC grid, this 4.2 megawatt grid from the public AC, and there we distribute that power, that DC bus, to the different charging stations via our DC-DC converters. One very innovative product we developed is our Arc Zero connector, because we need to give the customer in certain industries the feeling they have and the knowledge they have from the AC world. Basically plugging something under load, as you know, from the socket at home. The story in DC is a little bit different, because we don't have any zero crossing. So this is a technical challenge, because there's an arc that will develop itself, but it doesn't extinguish due to the phase as it is in AC, because we don't have any phase and we have a constant current flow. Therefore, this arc connector is electronically suppressing the arc, and this device is capable of disconnecting 800 volts and 20 amps without having an arc, with a very secure operation for the people that work on that device. Actually, we have an example of that device, which is very fancy and very cool to see, because we really make it blow over there, because we show how it is done with a classical connector instead of with an Arc Zero connector. So everybody here is very welcome to see us at the booth. Another one is our smart circuit breaker, because in DC grids you need to trip short circuits very fast. So classical mechanical circuit breakers doesn't work there, but that tripping time is 10 milliseconds. We need to be 1,000 times faster, and this device is very overcoming and helping in that matter. It's basically a semiconductor in combination with a relay, and if you have a short circuit, this guy trips within 10 microseconds or even less. And last but not least, as I said, the grid management is a very important part, also at the Geldhauser project. We also, when we then go in the second and third step with the energy storage and the PV, the energy flows needs to be managed in a way that we have the most benefit out of the system. And as I said, we already had a lot of knowledge from the AC world, and we adopt that to the DC world, since we have the power supplies and the high power modules in our portfolio. We use PLC Next our PLC Next platform, to use and manage the power parameters per sector, so to say, the power parameters for the battery storage, for the PV, for our production, and for EV, and merge that to a global ecosystem in terms of energy management. And data like weather forecast, stock market prices, the usage of the production, the usage of the EV. In that manner, we really put this whole system to one working global holistic solution, which gives us a big benefit in terms of stability, a big benefit in terms of self-consumption of the produced PV power, and last but not least, we really can manage to charge the battery when it's necessary. We can really manage to decrease the consumption of the EV. So this system makes it very, very smart and brings the full leverage and the full advantages of the DC technology. So that is the closing statement from my side. What I always tell when I meet people here at the booth is, we don't talk about DC technology, we make it happen. DC technology are ready, able to be built with strong partners like ISAC. We are the first contact for you guys. If you are interested in DC technologies, we have the right components, we have the partnership to make that happen for you. Thank you.
And we have, like, on the next slide.
There you go. Yeah,
if you'd like to contact us, feel free to scan the code to have a short introduction.
Of course. And everybody that is here, you are highly welcome to see us, our booth, and learn more about DC technology.
Thank you.
Thank you.